Welcome to the lesson on onboard diagnostics, abbreviated as OBD2, and its importance in the automotive industry. In this lesson, we will address the role of OBD2 in diagnosing and resolving issues within a car's system. Let us look at our lesson objectives. By the end of this lesson, you will be able to explain the purpose of OBD2 standards and how to read and interpret OBD2 codes. You will also be able to explain how OBD2 codes help diagnose what is wrong with the car, and finally, you will be able to explain the importance of OBD2 in the automotive industry. OBD2 was mandated to establish a standardized system for monitoring a car's emission control system and alerting drivers to potential problems. This allows for early detection and repair of emission-related issues, ultimately reducing air pollution. The Engine Control Module, abbreviated as ECM, or Powertrain Control Module, abbreviated as PCM, is the brain of a car's engine. It's a computer that continuously monitors various engine functions using sensors and adjusts them using actuators to ensure optimal performance, fuel efficiency, and emissions control. The ECM acts as the control center for gasoline or conventional cars that have internal combustion engines, abbreviated as ICE, monitoring various sensors and modules throughout the car. When any of these components detect a fault, they communicate with the ECM, which then triggers the illumination of the check engine light. A BEV has electronic systems controls, but no ECM since there's no combustion engine. However, the concept of a warning light system is still very relevant. BEVs use a dedicated module that monitors various sensors and modules, for example, serial gateway module. The modules are known by different names across manufacturers. When various sensors and modules detect a problem, they communicate with those dedicated modules. Upon receiving a fault code, the dedicated module will illuminate a warning light on the dashboard, just like the check engine light in gasoline cars. In a BEV, just like gasoline cars, a diagnostic trouble code, abbreviated as DTC, acts as a specific flag for a detected problem. Think of it like a cryptic message from the car's computer. A DTC is a combination of one letter followed by four numbers, like P1442. The first letter identifies the general area of the fault. P in this example stands for powertrain, a common category in BEVs that includes electric motors, batteries, and related systems. The four digits provide more specific information about the fault. Each specific code corresponds to a unique fault within that area. P1442, for instance, might indicate a problem with the battery voltage sensor. By understanding DTCs and their corresponding fault locations, you can narrow down the issue, and by referencing service manuals, you can determine the exact cause of the fault and the necessary repairs. In this section, we will focus on how to read onboard diagnostic, abbreviated as OBD2 codes. OBD codes are a subset of diagnostic trouble codes, abbreviated as DTCs, specifically used within the OBD system, which is a standardized system mandated for vehicles to monitor and report on their emission control systems and other key engine components. OBD codes help identify issues related to emissions, engine performance, and other critical systems. Both DTCs and OBD play a crucial role in diagnosing car problems. DTCs provide the specific error message, while OBD2, in applicable vehicles, is the system that generates and manages these codes. OBD is a network of sensors that track various functions and generate DTCs when issues arise, whereas DTC displays a specific code indicating a problem, but not the exact cause. Think of OBD codes like the restaurant's entire monitoring system. It includes various sensors, like thermometers in ovens, that constantly check different areas and functions, like cooking temperatures. These sensors feed information back to the digital display, which can then generate DTC's error messages. Think of DTC like a specific error message displayed on the kitchen's digital display. It pinpoints a general problem within the kitchen. For example, the code burning_smell indicates an issue but doesn't tell you exactly what's burning. Think of DTC as the what error message, and OBD as the how monitoring system that detects the problem and generates the message. Now, let's break down how to read the OBD2 code by looking at the example on your screen. The first character is letter P for powertrain. The second character is number 0, which tells us it is a standardized generic code. The third character is number 3 that tells us the location of the subsystem. The last two characters that are numbers 0 and 2 tell us the specific code or fault in the subsystem. Let's look at each of these characters in the OBD code and how to read them. The first character is going to be a P, C, B, or U that is going to indicate the basic subsystem. Powertrain, abbreviated as P, is the most common for gasoline vehicles and signifies a problem related to the engine, transmission, or drivetrain. Chassis, abbreviated as C, indicates an issue with mechanical systems outside the passenger compartment, like steering, suspension, or brakes. Body, abbreviated as B, points towards a problem with components found within the driver's cabin, like airbags, seat belts, or comfort features. Network U indicates a malfunction within the vehicle's network communication system or onboard computers. The second character will either be a 0 for the Standardized International Standard Organization, abbreviated as ISO, or Society of Automotive Engineers, abbreviated as SAE, generic code, or a 1 through 4 for manufacturer-specific code. On the third digit, let us break down which subsystem is affected. We know from earlier that it is a P code, which tells us that it is a powertrain code, but for a powertrain, we need to know more information. So we can either have 1 for secondary air injection, 2 for fuel system, 3 for ignition system, 4 for exhaust monitoring system, 5 for idle speed controls, 6 for input and output signals, and 7 and 8 for transmission systems. In this example, we have the number 3, so we know it is related to the ignition system. Keep in mind that this third digit could also be a letter, for example, A, B, or C, specific to hybrid or BEV propulsion. Lastly, let's look at the two numbers at the end together. In this example, the code displays the number 02, indicating a specific fault description of a misfire on cylinder number 2. In some cases, the fifth number could also be a letter. However, this is manufacturer specific. To summarize, the first thing we need to look at is what basic subsystem is the fault in. Second, what is the type of code? Third, which specific subsystem is the fault located in? And fourth, which specific code in that subsystem are we looking at? The fifth number could also be a letter. However, this is manufacturer specific. This is a chart of the mandated codes across different vehicle platforms. This is an example of a chart that is used in service information to help diagnose and determine what is wrong with the vehicle. In this section, we will focus on the categories of diagnostic trouble codes, DTC, including powertrain, chassis, body, and network. Let us look at the four main categories of diagnostic trouble codes. They are powertrain, P codes, chassis, C codes, body, B codes, and network codes, U codes. Powertrain codes are codes that are set related to the engine, transmission, and drivetrain. On your screen is a list of codes that you may notice on the diagnostic scan tool. Chassis codes are codes that are set related to mechanical systems such as the brakes, suspension, and steering systems. On your screen is a list of chassis codes you may notice on the diagnostic scan tool. Body codes are the codes that are set related to the driver's cabin, such as airbags, seat belts, or comfort features. On your screen is a list of body codes you may notice on the diagnostic scan tool. Network codes refer to issues within the vehicle's communication network. These codes identify problems with the communication protocols, data systems, or modules that are responsible for exchanging information between various components in the vehicle's electronic system. On your screen is a list of network codes you may notice on the diagnostic scan tool. In this section, we will focus on the importance of the OBD2 standard in the automotive industry and its general relevance in the industry as applicable to all vehicles. OBD2 has revolutionized the automotive industry by equipping technicians with a universally standardized set of diagnostic codes applicable across all vehicle manufacturers and models. This exceptional standardization has simplified the intricate process of diagnosing automotive issues, enabling technicians to swiftly and accurately pinpoint problems within a vehicle. As a result, valuable time is saved, and costs are significantly reduced in the repair process. OBD2's role in streamlining diagnostics has increased efficiency and elevated the overall quality of automotive maintenance and repair practices. When the check engine light illuminates in a gasoline car, the system actively generates a unique error code corresponding to the malfunctioned area. This error code can then be retrieved using an OBD2 scanner, providing valuable diagnostic information that identifies the area where the issue needs repair. OBD2 helps to ensure that vehicles follow emissions regulations, reducing air pollution and protecting public health in several ways. First, OBD2 monitors the vehicle's emission system in real time and detects when there is a problem that could cause the vehicle to exceed the emission standards set by regulatory agencies. When such a problem is detected, the OBD2 system generates an error code corresponding to the detected issue. This standardized process allows technicians and mechanics to quickly and accurately diagnose the problem and make the necessary repairs to ensure that the vehicle operates within the emission standards. This helps reduce the number of harmful pollutants released into the air, which can contribute to respiratory problems and other health issues. Second, OBD2 provides a way for regulatory agencies to enforce emission standards by requiring vehicles to pass emissions tests. Depending on the states within the U.S. or internationally, an emission test might be required. During an emissions test, an OBD2 scanner is used to read the error code stored in the vehicle's OBD2 system. The information is compared to the emission standards set by regulatory agencies. Third, if the vehicle is not in compliance with the emission standards after the emission testing, it will fail the emissions test and must be repaired and retested. This process helps ensure that vehicles on the road follow emissions regulations and do not contribute to air pollution and public health issues. Unlike gasoline vehicles, there's currently no legal requirement for EVs to comply with the full OBD2 standard. This means they may not have the standardized diagnostic port or necessarily use the same communication protocols. Many EVs, especially those with hybrid powertrains, do have OBD2 ports and can communicate using the OBD2 standard for certain data points. This allows technicians to use standard tools to diagnose some issues. However, for purely electric parts of the EV drivetrain, battery, electric motor, etc., the information accessible through OBD2 might be limited. Manufacturers use proprietary systems for these components, requiring specialized tools for in-depth diagnostics. Currently, OBD2 functionality in EVs is a mixed bag. It can be helpful for some issues, but may not provide complete diagnostic information. The future looks like there will be a more standardized system for EVs, but it's not quite here yet. Let us now recap what we covered in this lesson on OBD2 standard and its importance in the automotive industry. The main purpose of the OBD2 system is to help monitor and diagnose modern vehicles. OBD2 acts as a car's built-in mechanic, constantly monitoring systems and generating trouble codes for potential problems. Understanding these codes, both generic and manufacturer-specific, is key to interpreting the car's secret language of trouble. By identifying and interpreting codes, technicians will be able to address issues early and keep the car running smoothly. OBD2 also plays a vital environmental role, ensuring vehicles comply with emissions regulations for cleaner air. Thank you.